In problem number 1, we are going to use an exponential model. And the model is the total amount after a certain amount of time. I'm going to have my initial amount, and then I'm going to have 1 plus my rate taken to the t power, which is my amount of time. So my initial value is 790 quail. So that's how I got 790. My rate is 31%, so 0.31. Then my amount of time after 2 years, that's how I got the 2 here. And I'm going to put it into the calculator just like this. And this is the number I got. I'm going to round it off to the nearest whole number. So that's how I got 1356. In problem 2 and problem 3, I'm going to figure out if it is a growth or a decay. And the way I do this, I look at my base. So my base here is more than 1, so that's an exponential growth. In problem number 3, my base is 7/13, so that's less than 1, so that makes it exponential decay. In problem number 4, I have number of squirrels after number of years of a forest fire. So I am going to look for a pattern in this table. If I go from, I'm going to look at my y values, which would be squirrels. How do I go from 25 to 50? Times 2. 50 to 100 times 2. And I notice all of these are times 2. So they want to know, how does the population change? Each year it doubles, or you could say it goes up by times 2. The next question they want me to do an exponential model. My initial value is 25. And it's double every year, so my base is 2, and my time is t. In problems 5 and 6, I'm going to graph. In problem number 5, my base is 1/5, so I know that's a decay. When I figure out my points, my graph needs to look like that because it goes down. So I'm going to plug in the easiest values. I am going to plug in -1. 7 times 1/5 to -1. -1 flips that fraction upside down, so it's 5. So 7 times 5, 35. That's how I got that point. And then I'm going to plug in 0. Anything to 0 power is 1. 7 times 1 is 7. That's how I got that point. I'm going to plug in 1. So 7 times 1/5 is 7/5. So I put all those values on the graph, and that's how I got that exponential decay. In problem number 6, my base is 8. That means the exponential growth. So my graph must look like that, a growth. So I'm going to plug in the same values. I'm going to plug in -1. When I go 8 to the -1, that flips it upside down. So I have 1/8. 1/4 times 1/8 is 1/32. So -1 gives me 1/32. So I'm going to plug in 0. Anything to 0 power is 1. That's how I got 0 1/4. And plug in my last point and plug in 1. 8/4 is 2. That's how I got 1/2. And there's my graph. In problem number 7, I am going to write as a log. Notice I have no log here. So I'm going to use the words to figure this out. My base is 7. So log base 7 of 49 is 2, because 7 squared is 49. Now I'm going to go the other way around. I'm going to make this an exponential function. I have a log. I want to make this an exponent. My base is 4, so I'm going to go 4 to the -2nd is 1/16. In problem number 9, I'm going to evaluate. And the way I'm going to do this, I'm going to make this exponential. 2 to the x power. So 2 to the x power is 1/8. 1/8 is negative first power. So I am going to factor 8. 2, 2, 2. So I have 2 to the x equals 2 to the -3rd. And number 10, I'm going to switch it to exponent. 7 to the x power equals 49. Factor 49, 7 and 7. That's how I got x equals 2.